Question 8 in 2008. Rectangle is inscribed in a circle of radius 5. Here it is here. Or is the point xy and O is the center, 0, 0. And the vertex of the rectangle is in the first quadrant, and theta is the angle between OR and the positive x-axis, and theta is between 0 and pi over 2. And the point xy can be written as a cos theta, b sine theta, where a and b are real numbers. Find the value of a and value of b. Okay, those that do applied maths, this is a giveaway question. You could just write the answer down, but for those of you that don't do applied maths and may not have seen this type of stuff, 5, we have our x and our y sides. So what can we say about x? It's adjacent to the angle, so cos is going to be involved here. So the cos of theta is equal to x over 5. So x is equal to 5 cos theta. So any point on a unit circle can be written as or, where or is the radius, cos theta or sine theta. That's what this question is going to show. And if we get the opposite, y is the opposite, the sine of theta is equal to y over 5. So 5 sine theta is equal to y. So the value of a and the value of b, well, a is equal to 5, as you can see. A is equal to b, which is equal to 5. Part 2 of this question, show that a theta, the area of the rectangle, measured in square units, can be written as 50 sine 2 theta. Okay, let's go back up to our diagram. We've just gotten some portions of the diagram. We got this side here, 2b, 5 sine theta. So we have, how many have we got now? We've got 10 sine theta is going to be the length of the rectangle, the width of the rectangle. Again, we have this side is 5 cos theta. So this is going to be 10 cos theta. So the area of the rectangle is 10 sine theta by 10 cos theta. 10 sine theta by 10 cos theta, which is equal to 100 by sine theta cos theta. And if you know your rules for trig, the 2 sine theta cos theta is equal to sine 2 theta. So if I factor out 50 here, I'm going to get 50 times 2 sine theta cos theta, which is equal to 50 sine 2 theta. So a bit of knowledge of trig is a powerful thing. Part 3. Use calculus to show that the area of the rectangle with maximum area is a square. So we have the area, we just got the area to be 50 sine 2 theta. So anytime we see max or min, we're going to differentiate and let it equal 0. So a prime theta is equal to sine goes to cos. So 50 sine 2 theta goes to 50 cos 2 theta. And we multiply by the differentiated angle, which is 2. So we're going to get 100 cos 2 theta. And we're going to let that equal 0. So for this to be equal to 0, cos 2 theta has to be equal to 0. And then the inverse cos of 0, you know your angles at this point, is equal to 90 degrees. So 2 theta is 90. So my angle that gives a max is when theta is 45 degrees. And we want to show that this is a square. So we just go back up to our area. We had 10 sine theta by 10 cos theta. 10 sine theta, 10 cos theta. And if theta is 45, you can see here each side is going to be the same. We're going to have one side is going to be 10, sine of 45 is 1 over root 2, and the cos of 45 is 10 times 1 over root 2. So therefore we have a square. And if we multiply 10 by 10, we're going to get 100 over 2 root 2, root 2 by itself, which is 2. So this is going to be 50 square units. This max area is 50 square units. And we were asked to show that the rectangle with max area is a square. Well, we've gotten the rectangle with the max area. And we've shown that yes, it is a square. Next part. Oh, find its max area. So we have that already done. And then on to the last part of this question. Part B, a person who is 2 meters tall and is walking towards a street light of height 5 meters at a speed of 1.5 meters per second. Find the rate of change. The rate just says rate, it's a rate of change question, at which the length of the person's shadow, x, cast by the street light is changing. So rate of change question. So what are we given here? Well, the first thing we're given is that L is changing in this direction at 1.5 meters per second. So the length of the shadow is changing over time at a rate of 1.5. So we have the LDT. Well, we're dealing with X. So setting up this rate of change questions, we know that the question is asking us, we're asked for X over time. Person's shadow changing X over time is the XDT. So we've identified that we have the LDT, and I'd have to multiply the LDT to get the XDT by the X, the L, so that the L's cancel. So we need to get what X is in terms of L. So X is equal to something in terms of L. So that's the secret to this question, or the key to this question. So what is X in terms of L? So let's look at a diagram. It should help us here. So let's look at this triangle here. They kind of have shown, kind of told us to use this. So we have this triangle here. So we have a 2 and an X. And what about the big triangle? We have a 5 and the bottom is L plus X. So using these similar triangles, because obviously that angle is the same, that same angle, right angle, third angle has to be the same. So similar triangles here, we can say that 2 over 5 is equal to X over L plus X. So 5X is equal to 2L plus 2X. And we said we wanted X is equal to something times L. So 3X is equal to 2L. So we have it now. X is equal to 2L over 3. And if we want the XDL, we can say the XDL is equal to just the constant in front, 2 over 3. So I can fill in my values now. The XDT, the rate at which the X is changing over time, is the LDT, which we got to be, that was given to us, 3 over 2, 1.5, 3 over 2, and by the XDL, which was 2 over 3. So that's just going to be the XDT to be 1 meter per second.